Hello, this is the Section 1.2 lesson. Section 1.1 we talked about whole numbers and counting numbers. In this section we're going to talk about decimals and negative numbers. So first let's briefly review what we talked about in Section 1.1 with regards to the place value system. In the place value system we start here on the right with our ones digit, and which represents one individual object. If we bundle 10 of those objects together, we get our tens place, or tens digit. If we bundle 10 of those together, we get our hundreds digit, and we just keep going on to the left. Well, if we start on the left and move to the right, we're going to represent that with this symbol dividing by 10 rather than multiplying by 10. Dividing by 10 here means that we're going to ungroup or unbundle that bigger bundle of objects into 10 smaller objects. So if we start off with our 10,000ths place and unbundle those, well then we get the thousands place. And if we unbundle those, we get our hundreds place, and if we unbundle those, we get our tens place, and if we unbundle those, we get our ones place. So in general, if we move to the left like we did up here, that means we bundle objects together. Specifically, we bundle 10 objects or 10 groups of objects together to get a bigger group. And if we move to the right, we can think of that as unbundling. And so this idea of moving to the right and unbundling is going to form the basis of how we define decimals. So if we're here at the ones place, how can we move to the right? Well, let's talk about how to do that. So if we start here at the ones place and we unbundle that, we're going to add a decimal point and we get our tenths place. And if we unbundle those, we're going to get our hundredths place. Okay, so what does that mean to unbundle a 1? Well, here this picture illustrates this. Here this long green strip represents one object, or one unit. If we unbundle that, that means we're going to break that up into 10 smaller pieces, and that's represented here with this dividing by 10. And so each one of those pieces is 0.1 or 1/10. When we talk about fractions here in a few sections, we'll formally define what we mean by that symbol 1/10. But for right now, let's just take each piece as representing the number 0.1 or 1/10. And so if we're at the tenths place and we unbundle that, that means we're going to take one of these tenths, we're going to break it into 10 smaller pieces, and we get our hundredths place. So each piece is 0.01 or 1/100ths. So that's what it means to unbundle one item. It means we're going to break it up into 10 smaller pieces. Now, this idea of unbundling an object into smaller objects is something that we see in everyday life. Here's an example with money. We think of money kind of starting off with dollars, and then if we unbundle a dollar or break that into 10 smaller pieces, well, we get a dime. And if we take a dime and break that up into 10 smaller pieces, well, we get a penny. And so this idea of unbundling an item into 10 smaller pieces is something that we see in everyday life. Here's another example, something we see in everyday life dealing with the metric system, and specifically lengths in the metric system. Think of a length as starting off with 1 meter, represented here by this long strip. Now if we break that meter down into 10 smaller pieces, we get a unit that's called a decimeter. Now that's a unit that we're maybe not all that familiar with, but if we take a decimeter and break that into 10 smaller pieces, each one of those pieces is called a centimeter. So a centimeter is 1/100th of a meter. So we could think of as though we started with a meter, we broke that into 100 smaller pieces, and we got a centimeter. Now if we take each one of those centimeters and break that up into 10 smaller pieces, what we get is a millimeter. Now this picture here looks a little funny. It doesn't look like we've really broken up anything. It's just like we've changed the color. But what happens is that each one of these millimeters is so small that all we're really seeing is the lines in between the millimeters. We're not really actually seeing the millimeters because they're so small. So then let's apply this idea to a couple of examples. Like let's take the length of 1.2 meters. What that means is that I've got 1 meter and then 2/10 of another meter. So I've got one of these up here and then two of these down here. We put those together and overall that equals our length of 1.2 meters. 1.23 meters means I've got 1 meter and then 2/10 of a meter and then 3/10 of a meter. So put all those together, that's 1.23 meters. 1.234 meters means I've got 1 meter, 2/10, 3/100, and then 4 1,000ths represented there. So there's one way of representing decimals with simple pictures like this. Now let's look at how we can represent decimals on a number line. And so let's plot the numbers 1.5 and 1.16. Now when we draw a number line, we start off with drawing a horizontal line. We put arrows on the end to indicate that the number line keeps going on forever. And then typically we put a long tick mark here to represent like the number 0. Typically we start at 0. We don't have to start at 0, but we often do. And then we'll go over some distance and we'll put another long tick mark and we'll label that with the number 1. And then we'll go over the same distance and we'll label that with a 2. And then go over the same distance, we'll label that with a 3. And we could keep going on however far we wanted. Okay. Now we want to plot these numbers 1.5 and 1.16, which have some decimals in them. And so let's plot some shorter tick marks to represent the tens place. So both these numbers are between 1 and 2. So let's put some short tick marks here. Let's put 9 tick marks. 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll try to space those out as evenly as possible. And so there, each one of those short tick marks represents a tenth. So now to plot the number 1.5, that means we're going to go over 5 tick marks from 1. So we're going to go 1, 2, 3, 4, 5. And so we'll put a dot there and we'll label that as 1.5. So there's how I plot the number 1.5. Now the number 1.16 is somewhere between 1 or 1.1 and 1.2, and so we'll go a little bit over halfway in between 1.1 and 1.2, and we'll put a dot there and we'll label that as 1.16. Now this picture here is maybe a little bit hard to read, but you see the idea of how we took that distance between 1 and 2, we broke that up into 10 smaller pieces, and then we went over an appropriate number of pieces. Now both of those numbers are between 1 and 2, and so on our number line it really wasn't all that necessary to put 0 and 3 on the number line. So let's redraw our number line, and we're going to kind of zoom in to that interval between 1 and 2. So I'm going to put a long tick mark here and label that with a 1. And then I'm going to put another long tick mark and label that with 2. And then we're going to put our shorter tick marks here, 9 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And so now this is going to make it a little bit easier to see where these numbers go. 1.5 goes right in the middle. So we're going to put a dot there right at 1.5. And then 1.16 is going to go somewhere about halfway between 1.1 and 1.2, or just a little bit past halfway. So we'll put a dot there, see if I can make that a little bigger. And so now we'll label that as 1.16. So that picture is a little bit easier to read. We zoomed out a little bit, and so we can see things a little bit better. But now let's plot just the number 1.16. Maybe I want to focus in just really on that one number. I don't care about the number 1.5. And let's look at how we could draw a nice picture of this. So 1.16 is between 1.1 and 1.2. So let's draw a long tick mark here at 1.1, and then another long tick mark at 1.2. So we're going to zoom in on just this interval from 1.1 to 1.2. Now I'm going to put short tick marks in between 1.1 and 1.2 to represent my hundredths. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and there we go. We should try to space those out a little bit better than what I did there, but that's not bad. And so now this first tick mark here represents the number 1.11. The second is 1.12. The next is 1.13, 4, 5, 6. And so I'm going to put a dot right here and label that as 1.16. And so this example illustrates that we can draw number lines in a lot of different ways. They've all got long tick marks and short tick marks, but exactly how we label them is up to us. We want to label things so that things are easy to read. Long tick marks don't have to be whole numbers. They can be whatever we want. Now let's look at how we can, another way of representing decimals, and let's use this example to motivate how we can represent decimals with pictures. So let's take the dollar amount 1.36. So 1.36 means that we've got $1, and then we have 3 dimes, and then we have 6 pennies. So that's what the dollar amount 1.36 means. And so let's look at it in maybe a different way of looking at this number. Instead of starting off with a dollar here on the left, let's start off with the pennies on the right. And let's think of these 6 pennies as like 6 units or 6 items. And so we're going to start on the right with those 6 pennies as a unit, or with each penny as a unit. And then a dime, well, a dime is 10 pennies, so that's like a bundle of 10. So the 3 dimes here, these are 3 bundles of 10. So I'll abbreviate bundles with just a capital B. So 3 dimes is 3 bundles of 10. Well then a dollar is 100 pennies, and so I could think of this as 1 bundle of 100. So we can think of this 1.36 as representing bundled objects, but we don't have to start on the left as to what an item is. We can start on the right for what an item is. So let's use this idea to draw a picture representing the number 1.36. And so our picture that we're going to draw here is going to look very similar to what we draw in the previous section. With whole numbers, we're just going to have to carefully define what each symbol means. So here, I'm going to start on the right with the 6, which is in the hundredths digit, and I'm going to let that represent 1 unit or 1 item. And so in my picture here, let's let a straight line like this equal the number 0.01. And I'm going to use the 1 digit like this to distinguish that from just a straight line. And so then let's draw a rectangle like this to equal a bundle of 10. Well, if I bundle 10 100ths together, I get 1/10. So a rectangle like that, or a square like that, represents the number 0.01. And then I'm going to draw a bigger box like this to represent a bundle of 100. Well, if I bundle 100 hundredths together, what I get is the number 1. So now my number 1.36, that means we've got 1 bundle of 100, we've got 3 bundles of 10, and then we've got 6 individual objects. 2, 3, 4, 5, 6. So what we have right here is a picture that represents that number 1.36. Looks very similar to pictures that we drew in the previous section. It's just that we have defined things differently. Now here, instead of a single line representing a whole object, a single line represents 1/100th of an object. Now let's draw a similar picture to represent the number 0.136. And likewise, we're going to start on the right to define what is a whole item. And so in this case, let's let a single line like this represent the number 0.001. So 1/1000th. Okay. So then a box like this, which again is going to represent a bundle of 10. Well, if I bundle 10 1,000ths together, I get 1/100th. And then we'll draw a bigger box here to represent a bundle of 100. Well, if I bundle 100 thousandths together, I get 1/10. And so here's my key for the picture that we're going to draw here. So now my number 0.136 represents, well, 0.1, which is a bundle of 100, and then 3, well, that's 3 bundles of 10, and then the 6, well, that's 6 individual items, 1, 2, 3, 4, 5, 6, and so here's my picture representing that number 0.136. Now notice that it's the exact same picture that we used to represent the number 1.36. The only difference is our key here, how we labeled things and how we define things. So this illustrates that when drawing these pictures to represent numbers, it's very important to give a key to define what each one of these symbols mean. A symbol like this doesn't have to represent one whole object. It can represent any decimal fraction of an object. And so make sure you draw that key before you draw the picture. Now the last topic we're going to talk briefly about is negative numbers and what do they mean. And we're going to give several different contexts in which to interpret negative numbers. The first context here deals with money. If we have the number positive $3, I could think as representing the fact that I have $3. Whereas if we have a negative $2, we could think of that as owing $2. So a positive money means that I have money. A negative amount means that I owe that much money. Let's look at another context, temperature. If we say the temperature is positive 65 degrees, that means that we're 65 degrees above zero. Zero is like a starting point with temperatures. And so if we're at a negative 5 degrees Fahrenheit, that means that we're 5 degrees below zero. So there's another context in which to interpret negative numbers. Let's look at a third context in which to interpret negative numbers, and that's dealing with number lines. And so the number positive 2.5, we could think of that as meaning that we're 2.5 units to the right of zero. Just like with temperature, 0 degrees is like a starting point. On a number line, 0 is a starting point. 2.5 means that we're to the right of 0, 2.5 units to the right. But if we're at negative 1.4, that means we're 1.4 units to the left of 0. And so let's illustrate what we mean by this. So let's draw a number line here. And let's put 0 in the middle. That's going to be our starting point. Now I'm going to go over some distance to the right. I'm going to put a long tick mark there. I'm going to label that a 1. Now this distance that I just defined here, we're going to call that 1 unit. And so then we're going to go over one more unit, put a long tick mark, put that as a 2. We're going to go over that same distance, put a 3 there. Now to draw negative numbers, we're going to go to the left. We're going to go 1 unit to the left, so that's going to be a negative 1. We're going to go 1 more unit to the left, that's a negative 2. And now the number 2.5, positive 2.5, we're going to go 2.5 units to the right, and we're going to put a dot there, so that's 2.5. Now negative 1.4, we're going to go 1.4 units to the left, so there's 1 unit, to the left, and then another 0.4 units. So 0.4 units is not quite a half of a unit, so we'll put a dot right there, and that is the number negative 1.4. Okay. So there's how we can interpret negative numbers on a number line. A positive number is a number of units to the right of 0. A negative number is the number of units to the left. So that's it for the section 1.2 lesson. Your assignment before next class period is to read the section 1.2 from the textbook.